Hey folks, welcome out there. Hey, there's two of us again today.
We are.
And we are back. Gary Petco's back with me this Monday. We're glad to have him. Happy
Thank you.
Veterans Day
Thank
today.
you.
And I know you were a veteran in
Desert Storm. That's exactly right.
So we're
Yes.
glad to have you. Math supervisor also for Knox County Schools. So again, folks, give us a call today. We're going to be looking forward to hearing from you. We're here to get two heads maybe better than one.
Let's hope so. Let's hope so.
And get through some good things. We had some great calls on Thursday. We're going to go back and hit those again too. But you know, some of you I know are getting kind of ready for a little bit of snow maybe tonight and all that. So let's get some homework done before you get all bound up to the snow. You may be back in school, you know. 844-686-2378. That's the number. Also, we have a call operator today. Let's go see Braden from Beard and Key Club.
Hey, Braden.
Get her busy. Get her busy, all right? She's here to help answer calls today. We appreciate it. Doing some service hours for the Beard and Key Club and ready to take care of you guys. And again, we'll talk to you live on the air. You just give us a call, 844-686-2378. Let's go to that problem of the day. Woo. It's a long one, Gary.
Let's get it started here.
All right. You want to read for us here?
Sure.
I'll let you read this time.
Deon's got a bag of money with quarters and dimes, so just two sets of coins. He has 20 more quarters and dimes. If the total value of his money is $17.25, how many does he have of each coin? How many coins, how many quarters?
Wow.
How many dimes?
I can hear this clank, clank, clanking,
Yes.
jangle,
I'm
jangle,
thinking the same
jangle,
thing.
all these coins as he carries them around. So basically two things we're looking for. We're looking for the number of quarters and the number of dimes here. So let's take a look and see what we want to do with this problem. A couple of ways, actually a lot of ways we could really work this thing out, but let's talk about it. We got some numbers that are important. Now, that's not 20 quarters. That's what, 20
More
quarters than dimes. That's an important clue right there. And like I say, I like to call them clues because, you know, that tells us something that we have to make sure in the final answer it checks back. It works back through. And we also know how much money he actually is holding in the bag, which is $17.25. Jangle, jangle, nickels, nickels. No nickels here, just quarters and dimes, okay? So, Gary, what do we think? What's the easy way to get this thing started? We need to get a couple of variables, maybe use...
A couple of clues.
And maybe two variable letters,
Two
perhaps?
letters. And you know, I think, let's go and define our variables, what we're
I
trying
like
to find. Let's
that.
go
I
for
like that.
D is for the number of dimes,
Okay. I'll write it down. I'll let you talk to me.
and Q is the number of quarters.
Okay.
Let's see what our clues can be for that.
Well, you know what? I think everybody out there knows a dime is worth, what, 10 cents? And a quarter is worth
25
So that's going to be important to us because
Right.
we're eventually talking about the total value
Yes.
relating from that. So let's just relate numbers right now. Let's go with the numbers. We got the D and the Q. Let's see if we can relate something there. It says 20 more quarters than dimes. All right. So does that tell me that there's 20 more quarters, right?
And you know, that throws a lot of people off. I
does,
think it's
doesn't it?
just a matter of just making it concrete. Let's just give an example. If I've got 10 dimes, then that means I've got 20 more quarters. So
Which would be
that's
30.
So that means,
10 and 30, that kind of thing.
so the quarters is 20 more than D.
Okay.
Q
so
is-
how about it? Let's call it Q equals, you were saying what? D
Plus
plus
20.
20. Got it.
There's my
All
first
right.
one.
There's your first one. Remember, quarters equals 20 more dimes than what you got. Okay? That's the story there. Now, total value. We're talking that 25-cent and 10-cent business coming into play. You want to go decimals or you want to leave the decimals on this?
You know, it's so much easier when we go without the decimals.
Okay. All right. I'm all for it. So I'm going to put it over here because we'll put the two little things going on here. How about it? So 25 cents for a quarter.
25 quarters.
And
25
how
times.
about 10 for the dime?
10 for each dime, 10 cents.
And we're going to get a big chunk of money. Let's change it all to cents since we're making those cents. And I think a lot of times that's a little less intimidating. There I went and put the decimal right back in, but we'll get it out of there. So we avoid the decimals, although think about these as number of cents, 25 cents, 10 cents, and whoa, 1,725 cents.
Cents. That's
All
exactly the way to put it.
Yeah, there we're going. So we keep it all consistent. That's what you want to do. Now, I'm looking at this thing and I'm thinking, what approach? Because we know we talk about graphing, we talk about with doing a system, because this is what we got here is a system. We don't have X and Y, but we've got D and Q. So we use substitution, and what's that, elimination, and when you get in algebra 2, you can probably even do some other great methods.
Get some matrices in there.
Yeah. On this one, I think we got it under control. What would be the best approach you look at?
Well, you know, students who have done this, they've just gotten through studying how to solve one equation with one variable. So now we got two variables. So let's make this look like what they just got through doing. Let's see if we can turn this into one equation
Okay.
with
In other
one
words,
variable.
we're going to make all Q's or all D's
All Q's
somewhere.
or all D's.
You know what? I'm going to go to a little approach that I like to look at.
Love it.
I call it, I box it, and we send it.
I love that approach.
And I draw the arrows because that tells you where it's going. You're taking Q and replacing it with, as you were going to say, D plus 20. So let's do that. Bring out a little distributive property. Everything else stays the same, right?
Everything else.
We haven't messed with anything else.
But now we've got that down to one equation with one unknown.
And distributed property time. And that really does look just as something you and your calculator can really become one with here. So let's see what happens. Let's distribute. More arrows.
More arrows to show how we're doing that multiplication.
Yeah. And that's going to give us what? 25D plus the what? Big?
That's going to be 500.
500? Yeah. Add 10D.
Oh, this is looking fun.
And all of a sudden, it does look a lot easier now. Got some D's to go together. Big D's, little D's, all sorts of D's. Where are we going to go with them?
Let's combine those D's. 25 and 10.
That's easy.
That's 35 D's. 35 dimes.
Yep. So notice, folks, we're going to find the dimes first, then we'll go back and hunt down quarters, which is going to be really easy. That's why we boxed and
Absolutely.
sent. Okay. Well, combined, let's move something. How about, let's move the 500 out of there.
Put that 500 to the other side by subtracting it off both sides.
We'll do that. A nice little subtraction property of equality in the game. And I'm running out of space, but we're gonna be all right. 35D equals
1,225.
Thank you. I'm glad some mental math does come along there.
love
It
it.
does come in handy, doesn't it? This is a 35, contrary to my ugly writing looks like, but it said 35 times D, so we got to divide. So at this point, calculator. I think we go calculator. Let's see. Divide it by how many was it?
35.
35. All right.
I think I know what the answer is going to be. It looks like it's going to be the same. 35.
Whoa!
That makes sense.
That's pretty cool. All right, so our number of dimes equals 35. Now, folks, keep in mind that D represents dimes, so let's put them right here. Put that up there so we don't forget. And that's why we define those variables,
That's
so we can go back
exactly
and
right.
fill them in. Now, we're going to take the D, just like full circle.
Oh, it's fun.
Bring it right back up here. Going to take it back up here, and we're going to substitute. That's why we call it substitution, because we do it double barrel time. We substitute going into the problem. We substitute coming out. And it looks like you've got Q equaling, what is that? 35 plus 20. Oh, easy street.
There we go.
Which we have what? 55.
55.
And those are our quarters.
And I think it's really important that you define them as number of dimes, not just dimes. So it's 35 dimes, because that's what it's asking for.
And
How
everybody's
many?
going, what's that hashtag of dimes? But it is. It's a nice shortcut for number also. And that's what we've got going there. So 55 and 35. Now, we know, you know and I know, and everybody out there is watching, I hope knows, that we got that first clue's satisfied. Got 20 more. All right. The question is, do we have, what was the amount we want? $17.25. All right. Or in this case, 1,725. Let's see what happens on the calculator. We'll go there, all right? Because it's pushing us here. So we're doing 25 times that, what, 35? Was that what we ended up?
25 times 55.
55. All right, let me hit that. Don't want to hit the wrong number at this point, that's for sure. And we're going to add that to, you said 35 times 10.
Correct.
Right? Which I think we could do in our head, but I'll still put it in there for the folks who are doing it at home with us.
Let's see if that equals what we're supposed to.
And notice, folks, that's a nice thing about these graphing calculators. You can just run the whole thing together. You don't have to do it in little snippets and bits and pieces. And it'll know what to do because order of operations. It's going to multiply, then add them. There it is.
Look at that.
So it checks out beautifully. All right. So there's your story.
It's a good question.
55 quarters, 35 dimes. Way to go. All right. And could we have done it with differently? We could have left the decimals in there, but you guess what? We'd still get the same
answer.
numbers here because it's just basically like multiplying everything by 100 on that one. So everybody, that's your start. Now, yes, going here. We have a number that's 844-686-2378. Braden is here from Bearden High School. She wants to hear from you. We want to hear from you.
How about our friends from Bearden High School calling us?
I think, get some of Braden's friends out there and some of our Bearden Key Club members, but also Folks all over East Tennessee, Middle Tennessee, Western North Carolina, how about it? Western Virginia, Southeast Kentucky. Oh my goodness, they're everywhere on this watching
Snow
this
hasn't
show.
hit you yet.
So give us a call. We would love to hear from you, and we want to go to town today. All right, so give us some calls, and we will get things rolling. Now, last week, I wish I could remember who it was. It was one of our, and I didn't get the name, and I can't remember who it was, but young lady who called in and had a great problem for us. And so what we want to do is go back and look at that problem, because I've got a few more ideas to go along with it. And it says, find the minimum value for the function. That's a crazy looking function, Gary.
It is.
Because that's not one of those I would look at and say, hey, that rolls off the tip of my tongue.
I know what that looks like. Yeah, we wouldn't say that.
Yeah. So and what she was telling me says she needed to find, this was like an f of y, I guess, or just y equals f of x, I guess we would have it here. And she was needing to find a minimum value as well as, well, she was looking for a maximum, but she couldn't find one.
Okay.
Because there wasn't one in there,
Makes
evidently.
sense. I can tell that wouldn't happen.
And because the problem is going to be here, we have an undefined situation at x equals 0. All right, so you're going to blow out at that point as it approaches 0 from either side. So I suggested, and she suggested, she says, well, we're supposed to do something with the first derivative. And I said, well, let's go for a first derivative. But first, let's write down what this function, I'm going to use the f of x here a little bit, just make it a little easier on us to see.
So know it's a function.
And yeah, and it's e to the x times, Gary, how about it? You're algebra pro. That's x to the what? Negative
1.
1. And I think that works in a nice way to get, and that's what we worked with on Friday a little bit, although I actually went ahead and wrote it as 1 over x, which we probably do in just a second, all right? But that was the function. Now, to find the derivative, and this was where we had to think a little bit, and she filled me in on, she knew her derivative rules and such. So basically, she took the f of the, what's in the, we'll say the derivative of what's first term.
Part,
yeah,
first term.
F for first term. What am I thinking? And it happens to be e to the x.
Right.
And then we go ahead and multiply it times what's in the denominator, which in this case would be
e to the negative 1.
X to the negative 1? Or
X to the negative 1.
Yeah, but so we're keeping it, right? As
exactly.
it is. Absolutely. Okay, I just want to make sure we're good on that.
Yes.
Now, here came the other part. We're going to subtract, because that's the way it works. Well, once we're going to subtract, actually we're going to be adding, but we're going to need to get the derivative of the second one. We're going to go ahead and use e to the x once again. The derivative of we're going to keep e to the x as it is. Now we're going to go for the derivative of what? X to the negative 1.
Negative 1.
So that's going to give us, what is the derivative of that? It's going to be negative 1.
Negative 1.
Times, 1 over.
X to the
I'm going to go ahead.
second?
So it'd be x to the negative 2, or I'm going to go ahead and use it 1 over x squared there,
Okay.
all right? And that would be the same thing. As what do? We subtract the exponent, and
Correct.
that's what goes on there with the negative exponents. So while we're at it, let's just go ahead and make this one go the same way. Especially since we started out in that kind of form. Plus, actually, it's going to be a negative e to the x times, I'm going to keep it 1 over x squared.
Okay.
And I'm doing that for a reason, because we're going to pull out a GCF moment here. I saw e to the x popping up here, and I thought, this is really making this a cool situation. And again, we're looking for the first derivative, we won't need the second on this. And there's going to be a reason. We didn't really establish that last Thursday, but we're going to get to the reason of that in just a little bit here. So it looks to me like we have, this is not, okay, let me go back here a second. I'm mixing modes here, Gary. Because this needs to get, I need to stick with what I'm doing here. So let's.
Go ahead.
Now, the thing was, I went with negative 1 here, and I should have left this as just x to the negative. I guess it's still going to function.
I think we're still good.
Okay.
You used the product rule rather than the quotient rule.
Yeah, and that was what I was doing. And I used the quotient rule on the other day, so that's what I wanted to get back to. So really, what I should have here is that this value was actually x.
X, because if we use the quotient rule, that'd be x. I see what you're saying.
So let's do that.
That works out easier.
Yeah, let's do that. So we got e to the x, and we got x minus 1 over x squared. Now we're where I want us to be.
Right.
That's what in my mind I'm thinking. Now, we're going to kick along here. By the way, folks, while we're doing this, we don't want you to get too mesmerized and too glassy-eyed. We're just going back through and reviewing a little problem we did the other day. I want you to give us some calls, all right, at 844, I get it right, 686-2378. All right, and the idea here is that we want to find a minimum value in this thing. What we need is that first derivative to equal 0. You say, well, wait a minute, where'd that come from? That's basically the idea, because that shows a maximum or a minimum depending on what our graph is going to look like. And in this case, we've already established it's not going to be a maximum coming up here because of the x in the denominator as it is. So we're looking for a minimum possibility. So let's play some algebra 2 here, maybe. All right. And my goodness, what do we need to do? We're going to end up with, it looks like something like, God goodness, I'm going to come up with, looks like if I pull this thing through, it looks like I'm going to get a common denominator maybe.
That's right.
And we're going to have x to the third minus 1 over x squared. I jumped a little bit there. Does that sound good?
That sounds right.
Yep, because that's going to be x minus 1 over x squared, which is basically what we have right there. And then what we got to do is figure out, well, what's x going to equal here? E to the x, whatever we put in there, we're not going to be able to get a 0 out of that. So we've got to worry about this part right here. So it basically boils down to what is x cubed minus 1 equal to 0 going to give us? And I believe it's going to be at x equals 1. Now, there's no way we can factor that, but it's going to be something crazy, complex, imaginary that's not going to fly in this game. Now, let's take this thing to the calculator, because I want y'all to see what we're talking about here when we're looking for a minimum, so we should have a curve that bottoms out somewhere in the game plan here. So let's see what we've got. We got y equals, and we start off with e to the x. We'll get it there. Find e, where are you? There it is. It's got to use second button. With e is the base of the natural logarithm. Well, it looks like we've already got that all in there.
You put it in there ready.
So let's see, I got it, that x. Because we used this last Thursday. So let's see if that's happy. It looks pretty good.
Looks good.
And let's see what happens when we graph it. See, there goes that little, that kind of like a little asymptote business going on here, where 0 just wipes out right through there. But right there is our low point.
And I like what you put right here, because the question said, what is the minimum value? And x equal to 1 is where the minimum value occurs.
And it's a relative minimum, actually, is what's going on here. And remember what happens, we said that's when this would go to 0. That's how we were able to get that 1. And we did a graph to begin with, and probably seen that going on. But this is another way of showing how it does. And a quick value, let's hit my favorite button, which is trace. Put a 1 in there and see where it goes. Now, notice what happened with x equals 0. We have no value. It's undefined at y. So x equals 0, that kind of tells me why we don't have a maximum on it. So or a minimum either in that respect. But we've got a relative one right here. Let's try it out at 1 and see where we go. And so the minimum value is actually e.
Oh, that looks really nice.
That really worked out nice. I wasn't expecting that when we did it on Friday. I'm going, oh my goodness, your maximum y or your minimum y is e. E to the 1 power. Right there it is. That's
Which makes sense. If you substitute 1 in for x in that function,
you're going to have e to the first power, which is simply e. So anyway, I thought it was a real cool statement there. Now, some of you are going like, oh my goodness, Robert, you and Petco are both geeking out on there. Yes, we do that from time to time. But we want to hear from you guys. All right, give us some calls out there. We're not trying to wear you out completely today. So we'll breathe it a little bit. But you had a good algebra. Now you had a little, actually, this was calculus.
And just think about it, folks. It sounds kind of like we did a lot of calculus. But really all you're doing is minimum valuable function. If you had a function that represents the sale of an item at Christmas time, and you had an equation that represented how much that sells, we want to know what's the minimum amount you would sell.
Yeah.
That's all that's asking for. What's the minimum amount?
And this is the case. That's what it is. So you've got this crazy-looking curve, but it tells a lot of information.
Absolutely.
It tells you a lot of information. It tells what you can reasonably do, and tells you other things when they're all in the negatives, maybe that you don't want to do. That would be a possibility there. Tell you what, let's get some calls. We've got Braden out there, and she is wanting to hear from you. I'm wanting to hear from you. Gary's wanting to hear from you. Beard and High Key Club today. Thank you, Braden, for helping us out. we need to have some phones ringing, all right? So I know a lot of people are probably anticipating they're not going to school tomorrow, so they're not asking, maybe not asking a lot of questions yet, but I think a lot of you are going to be at school, but you may be going a little late. You may be going period, all right? So it's a lot of it depends on where that weather goes. What do you think? Should we go to something kind of, let's do a little fraction here.
Let's get back to fractions.
Yeah, decimal and fraction. And if I'm hearing a phone ring, and if you'll buzz us in through there, if they've got someone ready to talk to us, we'll be glad to break away from what we're doing here. But this is kind of a little bit of a maneuver, what we're going to look at in our actually specialized segments this Friday, this little show that we've got going on, is how to change a repeating decimal into simplified fraction. And it's kind of, and this one's a little complicated.
It is.
To look at, because it's really easy when we put just one decimal place or we have the bar over the whole thing. But this is a split act.
It is.
It's a split act, which I think makes it a little more interesting and fun to do. I had to refresh my memory when we looked at the first time we looked at a problem like this. But question is, will it, and of course we'll use the calculator to say, will it get us back? And that will be an easy stretch there. So let's talk about it here. And like I said, again, folks, give us a call. We're more happy to hear from you, and we'll break away from this little problem. But the situation here, we got n equals, and I'm just going to put it down here because I like to use n's.
Some number.
Yeah. And the idea is we're going to eventually get that n to equal two integers over each other that will give us that thing exactly back. Okay?
That's right.
And that's the hard thing, is because how do we call that? Do we call it 6/10? We call it 6600ths? 666 thousandths. I mean, I can go on, and it's each time you get a little more precise, but you're never done. You are never finished with that little sucker. So, if we could isolate,
if we could get that part out,
that repeating part, and get rid of it. So what I'm going to do out here, I'm going to multiply by 10 because that'll at least get me something going on here. Does that make sense, Gary?
I love that.
And I'll still have my repeater going there. But what I did, I just shifted the decimal. That's powers of 10. All right, so we just moved it over by 10. So what happens if we do it again?
Well, same, as long as you multiply on both sides.
That's true. So let's bump it up another power.
Okay.
Now you say, Ernie, why are you doing that? Well, let's see if I can figure it out. Oh, look. I just simply now moved that to 16 with a repeating decimal. It's just because I moved the decimal 1, 2 places.
That's right.
And what I'm going to do is I'm going to just do some good old arithmetic.
I love that.
I'm going to simply subtract these suckers, all right?
Because now you're getting rid of that crazy part.
You keep the ends, and we got what? 100 minus 10, which is going to give us 90. And over here, say goodbye to the repeating part, which is what the whole point of it was, right? We'll have a 15. Now, Mr. Petco, what are we going to divide by?
Let's divide both sides by 90 because we want to know what n is equal to, not 90n.
All right. And I'm seeing definitely those go away.
Right.
Can we get, I guess we got some reducing going on over here that'll work. I see 5s will go.
5 goes.
Let's do that first and see what happens. What is that going to be? 3 over 18?
For 18?
I think
we
so.
can do it one more time.
Oh my goodness, let's do a 3. And we get 1/6. Now someone's going, is it always going to work that way? You get 1/6 to give you 1.
Yeah.
Well, with that number there, but will it work in other respects? I'd say if we put 5, 6 there, it wouldn't be so lucky. No, it wouldn't have that luckiness. So don't everybody get all excited and say, oh, we really got a shortcut. Because I know a lot of times I'm looking always, will it always work this way? So let's go and check, once again, check on our little calculator and see what we get. And y'all, hopefully we're going to have a good result here. 1/6.
That's it.
Drum roll. Brum, brum, brum. There it is. Now they did cheat us a little bit because they ran out of 6s. But so they bumped it up and rounded off there. But the idea is it's still repeating. The 6, 6, 6, 6, 6 goes on. And folks, you can see a lot of that this Friday on this, on this Thursday on our specialized segments. We're going to do a little special show with that. And also this Friday, we're going to be doing one of our visits to Powell High School is going to be re-airing. So you don't want to miss out on those specialized segments. They're special shows and they're a lot of fun. And this one is going to give you some more chances to deal with those things. Gary, I want to thank you again for being here.
Thank you.
And I'll go back and thank you for also, and on behalf of a lot of our viewers and such, for your time that you've stayed with Desert Storm, that you've worked with
thank
that.
you. And all the
'Cause
other veterans out there.
it's such an important thing that you've been able to serve our country. And it's a Veterans Day. So folks, to all your veterans out there, thank you. And also, tell your friends who are veterans, thank you also
Absolutely.
for helping make this country free and a great place to be, and that we don't have to worry so much about how we live and what we get to do. Again, thank you for coming
Thank you.
on
I
today,
enjoyed
Gary
it.
Petco. Bearden out there, let's go back to Braden. And Braden, thank you for being with
Thank
us
you,
today.
Braden.
You did a good job, and I hope we get some more calls in here as we work tomorrow. And Wednesday, we'll be back again live. And Gary, I'm glad you could come in for a day. We'll get you back again next
Monday. That's right.
And you know what? And to each of you, thanks for tuning in, and we'll see you again next time.